Guys, we're live. All right. Okay. So anyway, we're just going to talk about section 3.4, part 1. These are pretty short notes. We're talking about solving exponential equations. Next time, we'll talk about solving log equations. What I want to do is I want to show you 3 methods for solving an exponential equation. The first one's kind of probably the easiest. The second one will be kind of middle. The third one will be more intense, but more universal. The first one's pretty simple. What you do is you rewrite each power with the same base. I'll explain what that means in a sec. But this is probably going to be the most efficient way to do this problem, if you can do it. It's kind of like if you have a quadratic equation, you could factor it. You probably would, because it's not as painful as like going to quad form where there's a lot more steps. The second one would be to rewrite the exponential equation as a log equation. You guys, of course, remember this. It's the same thing as saying that. We've talked about that, right? X equals b to the y is log base b x equals y. That's how you shift from exponential equation to log equation. We know this. We've done this before. And the last step would be to take, for the last method, take the log of each side and use power properties to move the exponent. Just so you know, this is more universal. It's more universal, meaning that it will work all the time. It's not terribly efficient, though, as you'll see, so sometimes you don't have a choice but to use it. The first one is probably going to be the most efficient, I would say. But doesn't always work. It's most efficient, but doesn't always work. You'll see why in a sec. Let me actually. Okay. So we're actually going to use all 3 methods for the first example, just so you see it. And then you can, of course, choose what you feel more comfortable with. But sometimes you have no choice but to use one of the other methods and not the others. So in this case here, if I use method 1, can I rewrite 16 as a new power with the base of 2? Yeah. 2 to the 4th, yep. There you go. 2 to the 4th. You fully rewrite 16. Now, if it was 15, forget it. I don't know what 2 to what power is 15. There is a power, but it's going to be weird. It's going to be 2 to 3 point whatever. That's hard to do mentally. This is a little easy. 16 to the power 2, very nicely. So because these are the same, those are the same. So 3x minus 8 equals 4. What's x going to equal? Good, 4. That's pretty simple. That's just method 1. Method 2, if you like, how do I write this log equation? Using this right here. Oh, that made it really hard if you guys see. Oh, what did I just do? Darn it. Well, that's just great. Okay, anyway, we know the process. Okay, now just highlight out of here. Okay, so how do I write as log? 16, right? Equals 3x minus 8. Remember, the whole purpose of log is to isolate exponents. The exponent was 3x minus 8. You write it as log equation, isolate it. And we should know to evaluate log base 216. What is log base 216? It's 4, right? X equals 4. So, pretty simple. Okay. Finally, method 3. I wouldn't recommend it unless you're forced to use it. Actually, I would have did this when I was in high school. I don't know why. I didn't really pay attention to this technique, but you take log of both sides. Maybe I chose this way because it's always a guarantee. It's a sure thing. You take log of both sides. It's fair treatment. You totally can do that. What happens to the left side? Where does that 3x minus 8 go? Yeah, it goes to the front, right? And what I did was that when I moved the 3x minus 8 to the front and multiplied the log 2 to be divided, which gets to the other side. And by the way, that's just going to equal 4, right? You still get the same thing. Use a calculator if you need to. Notice I did common log. Went to log both sides for method 3. You could use ln if you wanted to. It doesn't matter. But log 16 over log 2 is change the base formula, which is log base 216. But use a calc if you need to. You get 4, solve for x. Go ahead, Maddie. That's cool. Okay. So you have different pathways. Kind of like if you're driving to San Francisco, you can take 101, you can take 280, you can take El Camino, you can take Caltrain. Got a lot of options. 2A is probably the best option, personally. I think 101 sucks, but they all get to the same place. That's kind of what we get here. Like, we're all getting to the same thing. You've got different pathways. So you want to be able to understand each pathway when sometimes some pathways are better than others. This enhances your understanding of the stuff. Now for the next example, we still could use method 1. Whoa. All right. All right. Let's listen to the sounds working. Okay. All right. We can still use method 1 because fortunately 27 and 9 are both powers of what base? Good. 3 cubed, 3 squared. I like that. So 3 cubed, x plus 3, 3 squared, x minus 1. And now be very careful. When you raise a power to a power, how do you combine the exponents? Excellent. You multiply. So 3, 3x plus 9, 3, 3x minus 2. Yep. So those are the same. So guess what? Those are the same. They have to. That's the whole point. 3x plus 9 equals 2x minus 2. Garrett, can I close the door, please? A little loud over there. So you get negative 11. Cool. We're good? Okay. You could have used method 3 if you wanted to. Method 2 would not have worked, just so you know, because in order for method 2 to work, you need just one exponent to write from exponential equation to log equation. But method 3 would have been fine if you wanted to do it that way. But personally, I think just rewriting the powers of new base is fine. Okay, let's move on to example. Actually, why don't you guys try these 2 on your own. I'll do it and freeze the screen, and I'll show you my answer. So go try C and D on your own. Just give you a bit of a push. Just give you a bit of a push. 125 is 5 cubes. 8 is 2 cubes. 4 is 2 squared. Just so you know. So I'll work it out, and then we'll move on to the second half of the notes and get these done pretty soon. All right, here's what I got. Okay, so you should get 3 and -12. So I just used method 1 in both cases. For both equations. So just easier to do it that way. Any questions? No? Okay. So let's encounter equation with method 1 does not work. That would be when you just can't rewrite the basis. So let's look at that, and then we'll do another one after that one, and you practice on your own. Okay. So in this case, when you can't rewrite the basis, method 1 is not an option. Or sometimes even method 2 may not be an option, as you'll see very shortly. Let's say we use method 2. So that means to rewrite as a log. So rewrite as a log equation. So how would I rewrite this log equation? Log base 5 of 134. Okay, do that. And then you have to use a calculator. I think it's 3.04. Remember alpha window option 5, and actually I'll have my calculator. I think that's what you get. Yeah, to do it there, yeah, you get 3.04. So it's roughly 3.04. So it's kind of an approximation. Now here, no choice but to use method 3. You have no choice. So we take log both sides. Log 5 x minus 2, log 4 2x plus 3. Okay, where do those exponents go? To the front using the properties. That's why I said these are the tools you need. By redoing this, Here's what we got. X minus 2 times log 5. 2x plus 3 times log 4. You got surrounded parentheses, very important. This is one messy. That's 0.7 roughly. I already did this with another class, so I'll just tell you. That's roughly 0.6. I am rounding, just so it's not terribly accurate. But really, it just becomes a linear equation, right? Just a linear equation with decimal coefficients. That's all. So you get 0.7x minus 1.4 equals 1.2x plus 1.8. Negative 0.5x equals 3.2, x equals negative 6.4. Does that make sense how I did that one? You have a chance to practice some homework. So again, take a log of both sides, move the exponents to the front, use your calculator. Use the calculator, and then you just have to distribute and combine like terms. So, okay, let me do one more with you guys. I'll have you guys do a couple for practice, then we're done. Okay, in this case, you always want to isolate the power. That's the power. Right, you have E as your base, 0.6x is your exponent. How do I isolate that? What do I do first? Add 3, and then before you log, add 40. So I divide the 40. So that's just pretty basic algebra steps, right? Just the way you would isolate any variable, you do the same thing. And then you're going to use method 2, right? It's log base E of 6 equals 0.6x, which is really just ln 6. And then use a calculator afterwards, which did this before, I forgot. Yeah, 2.99. Add 3, divide 40, convert to log. Okay. Any questions about that one? All right. If you want to try D and E on your own, I'll do it as well. And you're going to use method 3 for part D. And you're going to use method 2 for part E. But isolate the power first. Oh yeah, you will need a calculator, by the way. But you can share with a neighbor if you want, just see what a neighbor gets. Yeah. Okay, here's what I got. What was that? Well, yeah. Okay. um, so notice I use method 3 for part D. Take a log of both sides. Um, move the exponents to the front. Use a calculator to figure out log 2 log 7r. Distribute. Becomes a very simple linear equation. Combine like terms, solve for x. A little nasty, so you just gotta be patient. And then e, add the 7 to the i6 power. Convert to a log equation. Use a calculator, solve for x. So have a chance to practice for homework. Any questions? No? All right, so I'll click through